Good morning, all. Today we are going to discuss certain topics in fluid mechanics and machinery. Okay, so I hope you had a wonderful morning. So, actually, this is regarding the course outcome 1. So, here we are going to discuss about basic properties of fluid, which every engineer should know in order to have a clear point understanding regarding fluid mechanics. Okay. So, we will be discussing what are the major properties of fluids. So, number 1 will be density, specific weight, specific volume, specific gravity, kinematic and dynamic viscosity, surface tension, and also capillarity. So, first property, very essential, is density. Okay, so it will be denoted by a symbol rho. Actually, this will be mass divided by volume. So, the unit will be kilogram per meter cube. So, this is actually with the increase in this temperature, what happens, you can just go through it. The volume of the fluid will be increasing and the mass density will be decreasing. So, this density is very important property. So, in case of fluids, what will happen? The pressure increases. We know PV is equal to MRT. So, pressure and volume are inversely proportional, right? So, the mass density will be increasing as the pressure is increasing. So, density of water, that is a standard, we consider as a standard in order to come out with a specific gravity calculations will be 1000 kilogram per meter cube. So, you can see that what it is, density, your honey, your corn syrup, your dish soap, your water and vegetable oil. So, they are based, these are the immiscible fluids and they don't mix with respect to each other. Okay. So, the density with regard for certain liquids and certain gases I have given as a tabular column. So, next is weight density or specific weight is actually it's weight divided by volume, which is Newton per meter cube. What will happen with temperatures increasing, the volume will also increase. So, PV is equal to MRT. So, what happens, this temperature is increasing, volume automatic increases and hence the specific weight will decrease. Okay, because they are inversely proportional. So, this is we call as with increase in pressure, volume decreases and hence the specific weight will increase. And next is specific gravity or relative density is the ratio S small s. It will be a ratio between the density of a given fluid by density of standard. So, normally we take it as water only. Okay. So, standard liquid is water, that's 1000 kilogram per meter cube, and standard gas we take it as air is 1.23 kilogram per meter cube. Next is specific volume. So, specific volume will be actually it is a ratio between the volume and mass. That's actually it will be a inversal of density. So, meter cube per kilogram. So, we know wherever temperature increases, volume increases and the specific volume also increases, right? Because they are directly proportional and the pressure increases, volume decreases and hence the specific volume will decrease. So, next we have the kinematic and also dynamic viscosity. So, we know very well what is viscosity. We know it is a property of fluid by which the fluid is offering resistance against the flow. Okay. So, we know very well in case of oil, the viscosity will be high. In case of water, the viscosity will be low. So, this in case of liquids, the viscosity is due to the cohesive forces, and in case of gases, the molecular activity between the adjacent layers causes it is the reason behind the viscosity. And what is very important is Newton's law of viscosity. So, we consider a liquid which has a fixed plate and also a movable plate, and they are at a distance of really y apart, and A is the contact area and F is the force required, which is required to move the plate with the velocity u. Right? You can see this is a linear velocity distribution and another one is a non-linear velocity distribution. So, next we know tau is directly proportional to du by dy. Tau is equal to nu into du by dy. This mu, this is called as the constant of proportionality, or otherwise it is the coefficient of dynamic viscosity. So, du by dy is the rate of shear strain or shear deformation, or else it is your velocity gradient, and the SI unit of viscosity is Newton second per meter square. So, viscosity is also defined as the shear stress required to produce unit rate of shear strain. This kinematic viscosity is actually it is a ratio between the dynamic viscosity and density of the fluid, and it's represented as a Greek symbol nu. So it is nu by rho, and we take it as in SI units. When you take it as a unit is meter square per second. In CGS or the CGS we take it as centimeter square per second, and in actually sometimes they give it a stroke also. Okay, so stroke also they give the unit. So what will be the effect of pressure on viscosity of fluids? So what happens is, when the viscosity of fluids is due to the cohesive forces, as I said already, as the temperature increase, cohesive force will decrease. So what happens? The viscosity will automatically decrease. But what happens in gases? The viscosity of gases is due to the molecular activity between the adjacent layers. As the temperature is increasing, the molecular activity will increase and the viscosity will also increase. Okay, next I have given the density, dynamic viscosity for certain gases and also certain liquids. We can see that values. Next is we can see the what substance at what temperatures, how is the specific gravity, dynamic viscosity, surface tension. You can just have a glance over it. And next properties of fluid is compressibility and bulk modulus. So bulk modulus is the ratio of the compressive stress or hydrostatic stress to the volumetric strain, and represented by factor K. It provides information regarding the resistance of the substance to the uniform pressure. Compressibility is a reciprocal of bulk modulus of elasticity, and it will be termed as the compressibility of the substance, and they both are inversely proportional with respect to each other. Okay, so this it is a reciprocal of bulk modulus, and we can see this how this is a small experiment to prove how compressibility is inversely proportional to bulk modulus. We have a volume of a cylinder, and gas is enclosed in the cylinder, and we are increasing the pressure, and how the volume is decreases V, that's minus dV. So now we are calculating the volumetric strain, and bulk modulus is increase of volumetric strain. Okay, this is a summary over these various properties with the symbols and with certain examples. I have given more formula also I have listed. This you can use it for your study purpose. Thank you for listening this video. We shall meet in the next video. Thank you all once again.